Right now, beneath the waters of Naples, Italy, something unusual is unfolding deep below the surface. During a routine monitoring operation in the Gulf of Pozzuoli, scientists detected a cluster of underwater structures that immediately raised concern. Sonar data revealed 12 massive mineral chimneys rising from the seafloor, each releasing superheated fluid, reaching temperatures close to 450 degrees Celsius. At that temperature, marine life cannot survive, and the surrounding water rapidly changes in chemistry and composition. These are not ordinary hydrothermal vents scattered randomly across the seabed. The structures appear organized and connected, forming a network directly linked to the volcanic system of Campi Flegrei. Early measurements show increasing gas emissions and continuous heat transfer, suggesting that the underwater environment is far more active than previously understood. Researchers are now closely monitoring the area to understand how this system is evolving and what it could mean for the region. More data is still being analyzed, and every new measurement is bringing scientists closer to understanding this underwater system. Subscribe now and stay with us as we continue tracking every new discovery and every warning sign coming from Campi Flegrei. The discovery didn't happen during a major emergency or a dramatic expedition. It started with a routine monitoring mission in the Gulf of Pozzuoli, where researchers regularly track temperature, gas emissions, and seabed movement around the volcanic system of Campi Flegrei. Everything initially appeared normal, just another weekly scan of underwater conditions. But when scientists reviewed the sonar images, something unexpected appeared on the screen. 12 distinct chimney-like structures were rising from the seafloor in a clustered formation, and none of them had been catalogued in previous surveys. These were not scattered hydrothermal vents randomly releasing gas. The structures were aligned, organized, and connected through what appeared to be a deeper geological network beneath the seabed. Each chimney showed signs of continuous fluid discharge and mineral buildup, suggesting long-term activity rather than a temporary event. What made researchers pause was not just the number of chimneys, but their arrangement and consistency. The data suggested a coordinated system operating beneath the surface, quietly transferring heat and gas through the underwater environment in ways that scientists are now working carefully to understand. As scientists continued analyzing the newly mapped chimney field, the gas emission data quickly became the most alarming part of the discovery. Measurements taken from the main vent area showed that the system was releasing approximately 50 tons of carbon dioxide per day, a level typically associated with active volcanic degassing. In addition to CO, researchers detected methane, hydrogen sulfide, and helium isotopes rising steadily through the water column, all of which are common indicators of deep magmatic activity beneath the seafloor. What makes this significant is not just the presence of these gases, but the volume and consistency of the emissions. Systems with this level of continuous degassing are usually connected to active magma chambers or high-pressure geothermal zones. In fact, the emission rate is often compared to volcanic systems such as Mount Etna, where constant gas release signals ongoing underground energy movement. This suggests that the underwater chimneys near Campi Flegrei are part of a much larger geological engine, slowly transferring pressure and heat from deep beneath the Earth's surface into the surrounding environment, while scientists continue monitoring its long-term stability. As researchers continued studying the chimney field, temperature readings began to reveal a deeper and more complex picture of the system beneath the Gulf of Pozzuoli. Mineral deposits surrounding the chimneys were maintaining temperatures close to 250 degrees Celsius, while the superheated fluids rising through the vents were reaching nearly 450 degrees Celsius. This kind of sustained heat is not typical for stable hydrothermal systems and usually points to ongoing energy transfer from deep underground. What concerned scientists even more was the consistency of the temperature increase over recent months. The change was gradual but steady, suggesting that heat and pressure were slowly building beneath the volcanic structure of Campi Flegrei. In geological systems, steady temperature growth often signals an active and evolving process rather than a temporary fluctuation. This means the underwater chimneys may not just be releasing heat. They could be acting as pathways for underground energy moving toward the surface, a sign that the volcanic system is continuing to evolve under careful scientific observation. As the underwater chimneys continued, releasing heat and gas, scientists began to notice another troubling signal. The surrounding marine ecosystem was rapidly changing. Areas that once supported diverse fish populations were becoming unusually quiet, with fewer species appearing in monitoring surveys and underwater recordings. The water chemistry around the chimney field had started to shift due to continuous gas emissions, making the environment increasingly hostile for marine life. Samples collected near the vents suggested that biodiversity in the area had dropped by nearly 70% compared to observations made just a few years earlier. Fish and small marine organisms that once lived near the seafloor were either migrating away or disappearing entirely, leaving behind a much less active ecosystem. In many geological systems, sudden ecological decline often reflects environmental stress caused by rising temperatures, toxic gases, or chemical imbalance in the water. Around the underwater network connected to Campi Flegrei, these environmental changes suggest that the seafloor is undergoing a transformation with heat, gas, and mineral activity, gradually reshaping the marine environment, while scientists continue to closely monitor the situation. While the underwater environment continues to change, the situation on land around Naples is also showing important geological signals. Over recent months, monitoring stations have recorded a steady increase in microseismic activity across the region, with small earthquakes occurring more frequently and spreading across a wider area. These are not large destructive quakes, but they indicate that pressure beneath the surface is actively shifting within the volcanic system of Campi Flegrei. At the same time, ground uplift has been observed in several zones around the caldera. The land is slowly rising as gas and heat accumulate in underground chambers, a process commonly associated with active volcanic regions. Small cracks have appeared in buildings, and sections of infrastructure such as tunnels and underground transport systems require regular inspection to ensure safety. Engineers and geologists are carefully studying these changes to understand how the system is evolving. Although these movements remain within monitored safety thresholds, the combination of underwater activity, rising ground levels, and increasing seismic events suggests that Campi Flegrei is a dynamic geological system that requires continuous observation and careful scientific assessment. To understand why these underwater chimneys matter, scientists are focusing on the deeper geological structure beneath the region. Campi Flegrei is not a single volcano, but a vast volcanic caldera formed by ancient eruptions, with a complex network of magma chambers, gas reservoirs, and underground fractures stretching beneath both land and sea. The newly discovered chimneys appear to be connected to this larger system, acting as channels that allow heat and gases to move upward through the seabed. In volcanic environments like this, underwater vents often serve as pressure release points, allowing energy to escape gradually rather than building uncontrollably underground. However, when multiple vents appear in an organized network and show increasing activity, scientists begin to study whether the system is adjusting to rising pressure or responding to deeper geological changes. The connection between underwater gas release, ground uplift, and seismic activity suggests that the entire caldera is part of one evolving system, slowly redistributing heat and pressure, while researchers continue monitoring its long-term stability and behavior. As scientists continue to study the evolving system beneath the sea, and land attention is increasingly focused on the potential impact on the city of Naples and the surrounding communities. More than 1 million people live within the broader area influenced by Campi Flegrei, making it one of the most closely monitored volcanic regions in Europe. In densely populated volcanic zones, even gradual geological changes require careful planning and continuous risk assessment. Small earthquakes, ground uplift, and underwater gas emissions do not automatically signal an imminent disaster, but they highlight the importance of preparedness and monitoring. Infrastructure, such as roads, tunnels, water systems, and residential buildings, must be regularly inspected to ensure they can withstand ongoing ground movement. Emergency agencies and geological institutions typically develop contingency plans to respond to different scenarios, ranging from increased seismic activity to potential volcanic unrest. For residents and local authorities, the priority is staying informed and prepared, while scientists continue collecting data, ensuring that any future changes in the Campi Flegrei system can be addressed with timely and coordinated response. To better understand the evolving conditions beneath the Gulf of Pozzuoli, scientists have established a continuous monitoring network designed to track every geological change in real time. Advanced underwater sensors, seismic stations, and gas measurement systems are collecting data around the clock, providing researchers with detailed information about temperature fluctuations, gas composition, and seafloor movement near Campi Flegrei. This constant flow of data allows geological agencies across Europe to analyze trends and detect any unusual acceleration in activity. One of the key goals of this monitoring system is to ensure early warning capability if conditions begin to change rapidly. By studying gas emissions, seismic patterns, and ground deformation together, scientists can build more accurate models of how the volcanic system behaves over time. The process requires patience and careful analysis, as volcanic systems often evolve gradually over months or years. Continuous observation helps researchers reduce uncertainty and provide clearer assessments, ensuring that any significant development in Campi Flegrei is identified and communicated responsibly. What is happening beneath the Gulf of Pozzuoli is a reminder that volcanic systems are constantly evolving, often in ways that are not immediately visible from the surface. The underwater chimneys, rising temperatures, gas emissions, and steady ground movement all point to an active geological environment connected to Campi Flegrei. While scientists continue to monitor the system carefully, the future behavior of this complex volcanic region remains uncertain and requires ongoing observation and research. Geological processes usually develop over long periods of time, and understanding them depends on consistent data scientific analysis and responsible communication with the public. For now, the focus remains on monitoring preparation and improving early warning systems so that any significant change can be detected in advance. Campi Flegrei continues to be one of the most closely watched volcanic areas in Europe, and every new data release helps scientists refine their understanding of the system. What do you think will happen next beneath Campi Flegrei? Subscribe to the channel and stay with us for future scientific updates and global geological reports.